welcome to Hands-on Arduino. Hands-on Arduino, Part 6B. In this presentation, we're going to be talking a little bit more about LEDs. In particular, we're going to be talking about 7-segment LEDs. So 7-segment LEDs are a type of LED that is often used for displaying alphanumeric numbers, values, usually numbers, but sometimes alphabetical characters as well. So in our modern world, LED displays are very commonly used. There are two types of commonly used configurations for LED, 7-segment LEDs. The first uses what's called a common anode. The second uses a common cathode. So anode and cathodes are part of the diode. Okay, so here I've shown the diodes just kind of lined up like this. Actually, they're arranged in a configuration like this, where sometimes they have a particular shape like this, where you have like edges here or pointy things, so that you get kind of rounded shapes like an 8, okay, which is supposed to be rounded, but obviously these guys are not very round. So that's one type of LED. Sometimes you just have them as square or rectangular blocks. So you can have it in either form. The main point is to be able to display either numbers or letters. So there are 7 segments altogether in terms of the number, and then there's an 8th, which is listed as the decimal place. And remarkably, even though there are different styles of LED 7-segment displays, the arrangement of the displays is very similar. So here, for example, we have A, B, C, D. It goes basically clockwise, and then G is the one in the middle, and then H is the decimal place, or sometimes it's just called DP, decimal place. Okay, and so even though the actual pins for a display element, okay, so this is like a single-digit display element, so even though the pins on them have different configurations, so this one has the pins on the end as opposed to the pins on the sides, so the arrangement can vary. So the arrangement of the pins is not necessarily related to how they're laid out. So A here is the first one. F makes sense. So that would be here. B is here. That makes sense. G is here. C is here. D is here, and so forth. So this is an arrangement. Okay, and so common anode. So these two are common anode type displays. This is these two are common cathode, so you'll see a CA or CC, common cathode or common anode. Sometimes it'll just say COM if it's a common cathode. It'll say COM. So in this case, it'll say COM or COM. You can also have some that have a decimal place on one side or a decimal place on the other side. That's a possibility as well. So different arrangements of these guys. In terms of actually being able to wire these up and hook them up to Arduino pins, we would have basically one of these two arrangements, depending on whether it's common anode or common cathode. Incidentally, if you're wondering how to remember what anode and cathode refer to, there's this acronym: anode, current, into device. That is, anode is the side of the circuit in which the current enters. The cathode is the side of the device in which the current exits. Okay, so the anode is this side of the diode, the cathode is this side of the diode. So that's how to remember. Anode and cathode are not commonly used with circuits, but clearly they are with LEDs. So this acronym, ACID, is an acronym that can be used in this situation. Okay, so here's our common anode circuit. We basically connect the anode up to a 5-volt supply. So the same 5-volt supply is actually connected to all the diodes. And so in order to get current flowing, since we have 5 volts on this side, we need a ground on this side in order to actually get the light to light. So a resistor is generally needed. I don't know why. You would think that since they're making a package out of this thing and they always need to have a resistance in there, that they would go ahead and put resistors in the package, but they don't. They don't. So you have to supply your own resistors, but that's probably fine because different people might want bright or light, or they maybe want to switch in one resistor or another resistor in order to make, you know, or a dimmer to be able to dim the lights. The user has to supply, or whoever works with these devices has to supply their own resistors. And so since this side needs to be ground, then basically this light is activated by the Arduino pin active low. That is, when this is a 0 or a ground, then you get the current flowing. So it's active low as opposed to active high. Okay. For the common cathode, we connect all the cathodes to the ground, and so to turn on the light, we need to actually have active high for the pin that actually connects into the Arduino. And so here we can work directly with the signal itself instead of its inversion. So in this case, when these are ground, then your Arduino, if this is connected to your Arduino and you assert it low, then you are sinking current. That is, the current is flowing into the Arduino, as opposed to this case in which the current, so if this is high, if these are high, then current is flowing from the Arduino into the LED. So in that case, the Arduino is sourcing current. In this case, the Arduino would be sinking current. And there are advantages and disadvantages to each. The Arduino is better at sinking current than it is at sourcing current. So this one is simpler in the sense that you don't have to do the inversion logic in order to get these to light. This has the advantage that you can actually sink more current, and so you can have the lights brighter. So 6 of one, half a dozen of the other. Anyway, when you buy these things, you buy them. You can buy them one way or the other, and so that's how we wire up the LEDs. So for a particular example, here this one uses a common anode. So we would basically hook it up with all the resistors, and so these are wired up this way. And notice then that in order to light these guys appropriately with consecutive pins, we would wire them up this way. That is, we would connect them basically in a clockwise fashion, starting with DP to C to D to E to G to F to A to B. So it basically goes clockwise. And so now, how do we know that this is the order? It looks kind of like a random orientation that these are, and so that's a very good question. And we will actually do an Arduino program to actually assess which ones need to be applied when and so forth, in order to evaluate which pins should be connected to which resistors and diodes. Okay, so having made these connections, we now connect digital pin. So the PD is port D, pin 0, port D, pin 1, and so forth up to port D, pin 7. So these are the digital pins 0 through 7 in port D. And so if we wanted, for example, to light up the LEDs to display the letter A, this is how the letter A would look, okay, like a capital letter A. We basically So notice that all of the segments are lit except for this one and this one. So that is, they're all asserted low. So these are all asserted low, except for this one, D, and the decimal point. Okay, so this is how we would define the segments that need to be lit in order to display the letter A. Okay, and so we could go through and do letters and numbers, whichever are going to work. So here is a list of some of the numbers and letters for this particular example. So A, B, C, D, E, F, G, H, I, J, no K. Well, it turns out that certain of the letters are not easy to reproduce using a 7-segment display. For example, the letter M, N, they're not so easy to display. So here I've displayed some ones that are pretty straightforward to display. Okay, and numbers. All the numbers can be easily displayed. And actually, that's why the 7-segment LED was designed. Was, well, first of all, it's 7 segments, and with the decimal point, that's 8. And since 8 is a kind of like a magic number with computers, that's why we have that. The other thing is since this was originally designed for numeric displays, and since we can readily do all the digits using the 7-segment display, that was enough. So if you actually want to do alphanumerics, then it's more common to use what is called a 14-segment display. So the 14-segment display not only has the ones around the sides, but it has like things that allow you to do X's and so forth, things in the middle. Okay, and so with this 14-segment display, then you can do full alphanumerics in a more naturally readable form. Okay, so here's the A that I showed before, and here's the hex value that's associated with that. And so I have not only the binary values that are needed, but also the hex values for that particular example. So when it comes to coding then, with 7 segments, there's certain letters like M, N, W, X. You can't really form those using the 7-segment display. So there are workarounds where some configuration of the LEDs represents those letters, but it's not at all natural. Also, some of the forms are repeats. For example, a 0 and an O, a 1 and an I. These are actually repeats of one another. They have the same codes, and so in certain configurations it might be confusing. As a result, we have limited message forms, but the important thing is that all the numbers can be handled. Here's another example. This is a common cathode display. Okay, and so again we have this kind of somewhat random order, and in this case the digital pins, they do not have to be asserted low, but here we have them connected in, and here is how we would do the display of the letter A. So notice in this case it's just the exact opposite. It's asserted high instead of asserted low, and again we can go through and do all of the letters we showed before. Also, if we were to include lowercase letters, we could actually get some lowercase letters that would be readable. For example, the letter N, the uppercase can't really be displayed this way, but the lowercase, actually you could have just the little 3 segments to make the letter N. And so there are certain letters that you can get using lowercase if you want to include uppercase and lowercase. So like the letter Q would be like the letter P, except instead of having this line, you would have one over here, and it would be the letter Q. So you could do some additional letters if you included lowercase. So again, here are the hex values for each of these things. Okay, so the first code I want to show is this code here, and what this code does is it actually goes through. Well, let's talk about it first. DDRD, Data Direction Register for port D. We write 1s to every bit in that register. What that does is that sets every pin in register D to or port D to be outputs. Okay, so rather than doing 8 pin mode commands, we can do this all in one single command this way. And then what we do is we're going to go through and we're going to light up all the LED segments one by one. So here we're going to shift. We're going to put a 1 in the whatever value K is, so cycle through the LED pins. And so this is what we're going to do. And so we can do this, and then we can identify what pin corresponds to which LED segment. And so back over here, when we had the wiring, it's like, how did I know that the DP, if we connected it to pin 0 and so forth, how would we actually find this out? Well, the program that I'm going to show you would show you basically it's going to light this one first, then that one, then that one, then that, and so forth. It's going to light them in a pattern, and then we can see what that pattern is, and then we know exactly how the LEDs are arranged. Then we can define the codes that are needed to program that letter. Okay, so that's what this is all about. Now, in doing this, I am actually going to do hands-off Arduino today in this particular presentation. That is, I'm not going to actually use a real Arduino. I'm going to use an Arduino simulator. The Arduino simulator basically allows you to create a computer version of the circuit and allows you to input your Arduino program and allows you to actually test everything out without physically having to wire up an Arduino. It's really handy. Okay. Now, there are actually quite a number of simulators, but I'm going to show you just one specific simulator. Okay, so here we are on the interwebs, and we have here a web page 123dcircuits.io, pretty cool web address. And what it allows you to do is it allows you to do breadboard circuits and simulation. So you can see it has an Arduino. Now, as I mentioned, there are a number of circuit simulators. Most of them are for Windows. I don't use Windows. I don't do Windows. So I can't use most of those. It turns out this one works under any platform where you can access the web. This can be used, and it works fine. It works great. So you can go here, and it wants you to actually, create an account, and so it has some account information, and it starts you off with a blank breadboard. Okay, you can go over here to components, add components, and so you can go ahead and I'm going to zoom out. So some of these commands that I'm showing, it's hard to actually show you what I'm actually doing because it's using my magic trackpad to do this. But some of it's like clicking and dragging kind of things. So dragging will allow you to zoom in and out. So I can take a resistor and bring it in here. Okay, each component can have a name to it. I'm going to let's see. Now, there's probably some way to make copies of things. I haven't figured it out yet. How to make copies conveniently. So there's probably a simple way of doing this. I don't know how yet. Oops. Okay, but the important thing is, here we go, Arduino. So I can add that as a circuit element in my circuit. Okay, so I can add all the circuits. I can do other things. For example, I can rotate components. Okay, let's see, to wire this, I'm going to go ahead and drag this guy over here. I'm going to click here, click there, boom, wired. So, more components. Let's see, what else have we got here? Somewhere, aha, here we go. 7-segment LED. Now this component, I'm going to rotate. There. Okay, so now this is connected to the breadboard. And so I can go through, for example, and so I went through the resistor. I can now connect this up to, I'm going to connect it up to here to a connector like that. And I'm going to go from here over to this. So that's the decimal point. Okay, so terminal DP is the decimal point. The next one over is terminal C. It's kind of hard to see these things. And so I can go through and wire up my circuit this way. Okay, now it turns out I've already wired it up. And so here it is, and I've rotated it. So here's the code that I just showed, the first code that cycles through the LED pins. Okay, so it has a setup routine, has the loop routine, just like the regular Arduino. And now I'm going to upload and run this program. So, notice I've got all these resistors connected up, and I have so notice I have ground going through here. Okay, that ground connects here. So remember that this is the common cathode circuit. So notice it says COM here. That refers to a common cathode. And so I also have a COM over here, and so both of these are ground. So this line here is all ground. This line over here is all ground. And so I only added these guys over here in order to make it so that I don't have any lines that cross right over on top of the display, so hiding the display. I also was able to change some of the colors of the wires in order to so you can see differences and things going on here. So I've connected up all these resistors, all 8 resistors. All right, and it turns out I only need to use connections on this side of the Arduino. Notice this is not a standard Arduino, but it does the job. I put in my code, and now I can do upload and run. And so it's initializing, and it started the simulation. So you can see it's cycling through the LED segments. And so you can see which segment corresponds to which bit on the in that port D. So based on that, I can, now that I know which pin connects to which LED segment, then I can go ahead and develop the code, or the code for each letter or symbol that I want to use. So that's the first program that I wanted to show you. And so having this nice simulator is really handy to be able to display all of this. Our next coded example involves using an array to form a message that we're going to broadcast by the LEDs. Basically, we're going to cycle through the characters defined by these codes. And actually, these are all the codes that I just showed on the previous slide. These are all those codes. So, and I'm just going to cycle through them. So it's not a particularly profound message. It's just the letters and numbers. And so we can go ahead and apply this code to Arduino. The same setup we just had over here. So this is here's my code. And so now I'm going to go ahead and upload and run. So it's compiling compiled successfully. Now it's going through and showing the letters A, B, H, I, J, L, O, P. It's going through all the numbers and letters just like we had. So that's the next illustration. It's nice being able to have a nice little setup like this. Our third example involves the letters SOS. We're going to put out a distress signal, SOS, that will be displayed on our Arduino. And so that's what we're going to do next. So here's our code. And actually, I went ahead and added a line here. So it's going to do SOS, and then it's going to blank this. Okay, so it's going to go through. So I upload and run, compiling, and now it's doing it. SOS blank. So here we sent a little message, help. So this is just an example of how we can use the Arduino, work with 7-segment LED, and do hands-off Arduino. That is, we can actually prototype what we're trying to do first using the simulation, and that way we don't actually have to physically do all the wiring. So it's very similar. This kind of wiring takes about as much time as physical wiring. But one of the nice things is, if I want a different resistor value, I can actually click on that and actually change the resistor value. So there are some nice advantages with simulations. So this is Hands-on Arduino, Part 6B, Hands-off Arduino. Thanks for watching.